This presentation is about the introduction and analysis of the advanced nature of the Topline G-Series track busway. Topline G-Series busway is the most high-end track busway product that we offer. In addition, there are Topline Economical, Topline Q Fixed, and Topline R, rack busway series. This is the power distribution structure of a data center. It is becoming popular that track busway replaces RPP and distributes power to RPDU at downstream of UPS. Why do we choose track busway? First, the construction cycle of the data center is relatively long, at least 1 to 2 years. On the other hand, the speed of IT equipment change is very fast because of Moore's law. Perhaps the capacity designed 2 years ago is no longer enough for the servers deployed today. It is obviously not feasible to use a fixed IT equipment power distribution solution to respond to the ever-changing IT equipment power distribution requirements. Second, the capacity of equipment continues to rise. 10 years ago, the capacity of a single rack was 2 kilowatts, and now about half of the racks have a capacity of 5 kilowatts to 10 kilowatts. Some data shows that the capacity of a single rack of some internet companies will rise to an average of 28 kilowatts in 2025. Some liquid cooling solutions have reached a capacity from 30 to 100 kilowatts. Therefore, as the power increases, the RPP solution with cables becomes less and less applicable. The cables become thicker and thicker, and installation and adjustment are inconvenient. The cables cannot be monitored, and it is difficult to eliminate potential hazards in advance. High-power cables generate a lot of heat and reduce energy efficiency. Third, the busway will make the power distribution structure simpler and easier for maintenance and adjustment in the future. In the case of raised floor air dispersion system, the removal of the RPP cable runs leaves more space for air distribution under the raised floor. The above 3 reasons make the track busway scheme more and more popular. The busway market of data center has a total of $660 million, and China is about $60 million, accounting for 12%. PDI and Starline can account for 50% of the share, which is quite concentrated. 35% of the solutions use small bus bars. Topline G busway is the most high-end series product we offer. It can provide flexible power distribution methods and is not affected by load changes. The products range from 160A to 630A, mainly composed of 5 parts: feeder unit, tap-off unit, housing section, L section, temperature monitor, connector, and related accessories, endover, installation accessory, etc., which can be flexibly assembled and configured for various computer room power distribution schemes. The characteristics of Topline G busway are safe and reliable, low temperature rise, intelligent, flexible, easy to install and expand. Let's explain each item in details. This is the internal structure of our bus bar. It adopts a 3-phase 5-wire configuration, and each phase row is arranged independently, wrapped with insulation, with good thermal conductivity. The current density of 400A and 250A bus bars is about 2.0. The full load temperature rise of the bus bar can be controlled below 30 K. The shell size of 160A 630A is uniform, so the same plug-in box can be used universally. Therefore, we can connect bus bars of different current levels and use them together to form a more economical solution. The specially designed elastic touch connector structure is used to ensure a reliable connection. A data cable slot is reserved for easy cable management. The left picture is the internal structure of the DC bus, and the right picture is the AC bus. The structure is the same. The DC bus has 2 sets of positive and negative copper bars and the common ground bar. For the tap-off unit, it is necessary to take into account standardization and safety while being convenient for customers to use. For the tap-off unit shown in the above figure, the 3-outlet scheme is the preferred recommendation, so that A, B, and C 3-phase all have outlets, and in the same tap-off unit, to avoid unbalanced power distribution or too many tap-off unit SKUs. For the same reason, due to the internal structural characteristics of the DC bus, it is preferred to configure the tap-off unit solution with 2 outlets or 4 outlets. This page describes in detail how to insert the tap-off unit into the straight section. First, buckle the cover under the bus bar, then insert the tap-off unit, insert it in position, connect the grounding position first, and then operate the handle. From left to right, the flexible contact fingers inside the off unit pop out, and then press and connect to the bus bar. At the same time, the cam rotates and is locked with the housing. After that, the 4 hooking devices can be hooked into place to complete the installation of the tap-off unit. The operating handle has an insulating sheath, and the metal beginning and end are grounded. The contacts are silver-plated, the deposit pressure of the contacts is greater than 150 N, and the travel of the contacts is 7 mm. Connection reliability analysis. First, we use special materials for the contacts to ensure electrical conductivity and good flexibility. Second, each flexible contact finger is independent and has a redundant design. The failure of a single contact finger will not affect the safe use. Third, the connection positions are all silver-plated to increase their electrical conductivity. Fourth, the copper bar under the contact finger has a spring, and the contact finger itself is elastic. The redundant elastic design ensures the service life of the contact, which can be used safely for more than 25 years. This page shows the tap-off unit designs of mainstream manufacturers on the market. The first type uses U-shaped copper bars and I-shaped plugs. After insertion, rotate 90 degrees and lock the position. The second type uses I-type copper bars, and the plug is U-shaped. After insertion, it is rotated 90 degrees and locked. Topline G series bus bars adopt I-type copper bars, deployed on both sides, and the tap-off unit contacts are pressed on the copper bars to take power. The advantages are as follows. 1. No need to rotate, saving operating space. 2. The operation is simple, without the risk of not in position, and it is safe and reliable. 3. The maximum outgoing line can reach 3-phase 100A. 4. Stable and safe structure, low temperature rise. The Topline G busbar connector adopts a unified design, and the 160-400A connector can be used universally. The connector adopts an integrated design, low temperature rise, safe and reliable, and the connection principle is the same as that of the tap-off unit. The temperature measurement module is equipped to measure the temperature at the connection. The busbar connector of Topline G is an integral part. Other competing products are generally composed of 2 to 4 parts, and the installation is reliable without special tools, which can ensure the installation is in position. The cover plate array is prefabricated at the jack below the Topline G. If you want to insert the tap-off unit at the corresponding position, open the cover plate and then insert the tap-off unit. If you want to adjust the position of the tap-off unit later, pull it out tap-off unit, then put the cover on. The cover plate can be designed with high protection rating, up to IP44. Protected against 1 mm objects and splash liquids. Topline G track busway can be equipped with an intelligent busbar system to monitor the power consumption of each branch of the tap-off unit and can form the cascade ring network to ensure the redundancy of information channel security. The measurement includes the voltage, current, electric energy, active power, reactive power, frequency, harmonics of the main circuit and the branch circuit, and each position of the busbar, including the temperature of the connection position and other parameters. The HMI screen can be installed on the side of the micromodule or the first cabinet in the cold aisle to intelligently display the entire busbar condition and upload it to the DCIM system. The straight section of the Topline G busbar is partly produced automatically, and the whole set of equipment has 4 invention patents. 6 workers can produce 300 m Busway straight section every day, ensuring delivery to the greatest extent. There are 3 ways of heat transfer: heat conduction, heat convection, and heat radiation. For the busbar, heat convection and heat radiation are almost negligible. Heat conduction is the main form. The performance of heat transfer mainly depends on the structure and deployment method. As shown in the figure, 3 different deployment methods of copper bars have different heat conduction efficiency to air. Under the condition of the same cross-sectional area, the same thickness, and the same heat generation, vertical deployment can significantly increase the current carrying value. Between the 2 copper bars with the same cross-sectional area but different heights and widths, the larger the side vertical heat dissipation area, the higher the current carrying value. This is the design principle of the busbar structure. In addition, heat conduction also depends on the transfer medium. Solids can transfer heat better than air. We wrap a large area of insulating material to effectively transfer heat to the shell, which can achieve the most efficient heat dissipation. Figure 2. Copper bars are densely deployed, and heat will be transferred between the copper bars. In addition, the horizontal deployment of copper bars will conduct heat through the air, which will make the heat dissipation worse. Figure 3, the special-shaped copper bar is deployed horizontally, and half of it conducts heat to the air through insulation, and the heat dissipation effect is not as good as ours. For bus bars and plug-in box contacts, due to structural reasons, the temperature rise below will be higher. Figure 4, although the copper bars are deployed vertically, the heat is conducted through the air, so the heat dissipation effect is not good. Let's take a look at the picture on the left first. The bus bars are densely arranged, and the heat dissipation effect of the special-shaped copper plates is not good. There will be heat transfer between phases, which will affect the heat dissipation effect. Topline G busbar, 400A and 250A busbar current density is 2.0A/mm2. Under full load condition, the temperature rise of busbar and connection position can be controlled below 30 K. For 630A products, the temperature rise at the connection is about 40 K, which is an excellent value in the industry. When hoisting the Topline G busbar, A and B rods are fixed by beams and hoisted together to enhance stability. Standard hoisting accessories are equipped per meter, and the seismic strength can reach level 9. The above are some project cases. The following are some live pictures of the busbar data center, which is a case of ceiling-mounted busbar installation. The busbar in the upper right corner picture is installed on the top of the cabinet, which is suitable for the situation where there is no hoisting condition, and the installation will not be affected by the environment, but this installation method will be more troublesome if it encounters a wall column. A large screen meter is used in the lower right corner picture, which can be tilted downward at 45 degrees. The display font is specially designed, and the detailed parameters of the tap-off unit of the busbar can be viewed in real time and clearly from the scene. The lower left corner picture is the scheme of the elbow when you shape deployment. Customers can deploy the busbar first, then adjust the tap-off unit according to the load. Thank you. Apislogik uses innovative solutions to solve customers' most difficult IT power distribution problems.